In example 16 and on page 87, we are asked to express 2 cosine theta plus 5 sine theta in the form of r. This is r cosine open bracket theta minus alpha. And from the previous examples, we have known that we are going to rely heavily on the addition angle formulae. And since we have known how to express cosine theta minus alpha in this format, then we know, of course, we know this is cosine, this is negative, so there's a positive somewhere. So from the cosine of theta minus alpha, which we know to be equals to cosine theta cosine alpha plus sine theta sine alpha, then it follows that if this has been expressed in this format and 2 cosine theta plus 5 sine theta was r cos theta minus alpha, and it is this part we have been able to express in this form, then 2 cos theta plus 5 sine theta is now equals to what we have expressed r cos theta minus alpha to be, which has been r cos theta cos alpha plus r sin theta sin alpha. And at that point, we just compare the terms. This first term has cosine theta, so we'll have to look for a term that has cosine theta across, and we can say this is the term. We can say r cos theta cos alpha is equals to 2 cosine theta. We have done that because we can be able to divide by cosine theta both sides. So to be left with r cosine alpha is equals to 2. And that is that. The second term, 5 sine theta, is to be compared with the other term across that has sine theta. And sure enough, r sine theta sine alpha is equals to 5 sine theta, so that we can come back here and cancel with sine theta on both sides, so that we can be left with r sine alpha is equals to 5. We have known that sine theta or sine alpha over cosine alpha is equals to the tangent of theta. And you can see there is sine alpha here and there is a cosine alpha here, which can also be termed to be 5 over 2. So when we clean that relationship up, we are going to have the tangent of alpha to be equals to 5 over 2. So with 5 over 2, we are told that there's an angle alpha whose tangent is 5 over 2. And what is that angle? It is just shift, tan, answer, or rather 5 over 2. And you find that alpha is 68.2 degrees. What does this mean? Well, we have the value of alpha. What we are remaining to calculate is now the value of r. And let us talk about the value of r now. If we bring the Pythagoras triangle here, which has to be a right angle, we have to talk about alpha here, which is 68.2. And because its tangent is opposite over adjacent, opposite is there, and 2 is there. Incidentally, 5 happens to be r sine alpha. 2 happens to be r cosine alpha. Of course, it goes without saying that r squared sine squared alpha plus r squared cos squared alpha is equals to 2 squared plus 5 squared, or rather, okay, it's okay because I have started with r squared r sine alpha. I should have started with 5 squared, but it's okay. There's no problem. The common factor here is r squared. Inside the bracket, there is what we know, we have known for some time now, sine squared alpha plus cosine squared alpha is equals to 4 plus 25, which is 29. And this follows that r squared, because this is just 1, is equals to 29, and therefore r is easily the square root of 29, the positive aspect, because r should be greater than 0. That is r. And we have been able to acquire the r, we have been able to acquire the alpha, so we can easily write 2 cosine theta, which was given to us initially, plus 5 sine theta to be equals to root 29, which is the r now, multiplied by the cosine of theta minus 68.2 degrees. And that is just like part A. There is part B. There is part B that is requesting us to. There is part B. Let's see what is in part B of the same question. We are told, hence, in part B, we are told, hence, or solve for 0 degrees, the value of theta from 0 to 360 degrees. The equation 2 cos theta plus 5 sin theta is equals to 3. The existence of the word hence means we have probably to use our results in the previous part, or rather part A, and this is what we just going to do. We know 2 cos theta plus 5 sin theta to be equals to root, we are talking about root 29, the cosine of theta minus 68.2 degrees to be equals to this. So this has been written in terms of this. Now this is what is equals to 3. And without further ado, we need to talk about dividing everything by the root of 29. We are going to have that the cosine of theta minus 68.2 is equals to 3 divided by root of 29. And what do we have? The cosine inverse of this now, 3 over root 29. If you evaluate that in the calculator, you will find, let's just do it, the root of 29, 3 divided by the root of 29. If you do this, you will realize that the sine inverse of this is if no, not the sine, but the cosine inverse. Shift cosine of answer, we're going to get 56.14 degrees. So there is an angle whose cosine is 3 over root 29, and that angle is 56.1 degrees to 1 decimal place. That is not a problem. Our problem is, but what was the cosine? If it means, therefore, then theta minus 68.2 degrees is 56.1 because there's a certain angle whose cosine was 3 over root 29, and that angle has been realized to be 56.1. That means if we take the whole of this bracket to be theta, then theta is now going to be 56.1 degrees. And you can see already theta is now equals to 56.1 plus 68.2. And let us see what is this. Plus 56.1. Let's see what is this. We are going to have 56.1 plus 68.2, which is 124.3 degrees. So on one hand, theta is 124.3 degrees. But it is this part of this question that I want people to concentrate so much. There's no problem finding that. If I consult the cast circle, all science teachers complaining, and our cosine is positive, so we realize that cosine is in the first quadrant. This is 56.1, and cosine is in the fourth quadrant, 56.1. So it would, and because there is an operation of adding 68.2 here, which is greater than 56.1, it would have been possible that the angle is also negative. It could also be possible that theta minus 68.2 degrees is also negative 56.1 degrees. This one is not quick to remember, but I want you to look at it this way. If we bring now 68.2 across, it will be added. So theta is minus 56.1 degrees plus 68.2 degrees, which is minus 56.1 plus 68.2 degrees, giving us which is 12.1 degrees. And 12 is well within the range. The range is between 0 and 360. So please note, since cosine is positive in the fourth quadrant, it would have been possible, because there is an addition of somewhere of 68.2 degrees when it gets across, it would have been possible that angle to be negative 56, and that the other part or the other value of theta. If we move on, probably we can talk about, let's try another round. And another round is probably 360 minus 56.1. 360 minus, it would have been possible 360 minus 56.1. That would also be possible, which is 303.9. So theta minus 68.2 degrees would have been possible to be 303.9. But look at theta. In this, if this is the case, it's going to be 303.9 plus 68.2 plus 68.2, which is 372.1 degrees. And this one is not included because it is, well, this one is not included because it's outside range. And that is why we can confidently say that our values of theta is 12.1 degrees. Theta is therefore 12.1 degrees and 124.3 degrees. All right.